Hi, this is Narayan from Shunya Technologies. Today I am going to explain Fibonacci series using recursion in Python. This is a continuation for part 2 Fibonacci series without using temporary variable in Python. Please watch part 2 before going to this video. What is Fibonacci series? Fibonacci sequence is a series of numbers where the next term is the sum of previous two terms. We will generate Fibonacci sequence using recursion. What is recursion? Recursion is a process in which a function calls itself as a subroutine. The formula to calculate Fibonacci series is f of n equal to f of n minus 1 plus f of n minus 2. For example, if you want to calculate for f of 5 equal to f of 5 minus 1, that means f of 4 plus f of 5 minus 2, that means f of 3. Fibonacci sequence starts with 0 and 1. Here 0 and 1. If you add 0 plus 1, we will get next term 1. Then if you add 1 plus 1, we will get next term 2. And if you add 1 plus 2, we will get 3. We will discuss this logic over Visual Studio. Launch Visual Studio and create Python application. We need to read input value from command prompt. Use input method. Input, please provide input value and store it in integer variable. Input number. Input method returns string value, but we are trying to store it in an integer variable. We need to convert from string to integer using int method. Int. We need to check input value is valid or not. If input number less than or equal to 0, print, please provide positive integer, else print Fibonacci series for I in range input number print recursive Fibonacci of I. We need to implement recursive Fibonacci method to generate Fibonacci sequence. Def, copy this method and pass argument. If n less than or equal to 1, return n, else return recursive Fibonacci of n minus 1 plus recursive Fibonacci of n minus 2. We'll execute this program without debugging. Go to debug, start without debugging or control F5. Please provide input value minus 4 and I am getting output as please provide positive integer. Control F5, 5, enter, and I am getting Fibonacci series 0, 1, 1, 2, 3. 0 plus 1, 1, 1 plus 1, 2, then 1 plus 2, 3. We will discuss this program over debugging to understand the flow of the execution. Put breakpoint, go to debug, start debugging or F5, and later we need to click step into or F11. Click on start debugging, F11. Please provide input value 5, enter. Input value less than or equal to 0. 5 less than or equal to 0, false. It will go to else false. Print Fibonacci series. Here we are using for loop. It will take values from 0 to 4. Here I is equal to 0 and input number 5. We are passing I value to recursive Fibonacci method. Here n is equal to 0. N is equal to 0. N less than or equal to 1. True. Return n. And here we are printing 0. Later n is equal to 1. 1 less than or equal to 1. True. Return 1 and print 1. Later n is equal to 2. 2 less than or equal to 1. False. It goes to else part. Here in else part we have recursive Fibonacci of n minus 1 plus recursive Fibonacci of n minus 2. N is equal to 2. We will get recursive Fibonacci of 2 minus 1, that means 1, and here 2 minus 2, 0. Here we will find recursive of 1 plus recursive of 0. Here n is equal to 1, 1 less than or equal to 1, return 1, and then we need to find recursive of 0, n is equal to 0, 0 less than or equal to 0, return 0. Here 0 plus 1, it will return 1 and print the value 1. Later n is equal to 3, 3 less than or equal to 1, it goes to else part. Here recursive of 3 minus 1, that means recursive of 2, plus recursive of 3 minus 2, that means recursive of 1. So this recursive function will execute for recursive of 2 and recursive of 1. F11, here n is equal to 2, 2 less than or equal to 1, false. It will calculate recursive of 2 minus 1 plus recursive of 2 minus 2, and it will continue. Control F5, 6, enter, and we are getting output as 0, 1, 1, 2, 3, 5. Here we have a problem with recursive function. We see what is the problem. For example, if you provide input as 5, then f of 5, then we need to calculate f of 4 plus f of 3. Here right side for f of 3, we need to calculate f of 2 plus f of 1. For f of 2, we need to calculate f of 1 plus f of 0. On left side, for f of 4, we need to calculate f of 3 plus f of 2. Then for f of 3, we need to calculate f of 2 plus f of 1. For f of 2, we need to calculate f of 1 plus f of 0. If you observe in this diagram, we are doing repeated tasks. For example, here we are executing f of 3 1, 2, 2 times. So we are calculating f of 2 1, 2, 3. So like that, so every time function is executing repeatedly, so it will consume process time. So we need to rectify this problem. In the place of recursive function, we can go to dynamic programming. We'll discuss dynamic programming in the future video. We'll execute this program without debugging. Control F5, 10, and we'll get output as 0, 1, 1, 2, 3, 5, and so on. That's it for today. If you like this video, please share with your friends and subscribe to my YouTube channel for future videos. Thank you for watching. Have a nice day.